Hello and welcome to this video lecture on solving some of the problems at the back of chapter 6 for the first part of the first week of what we're covering. And so what I thought I'd do is go ahead and do problem number 4. I've already opened up the Morningstar Excel data file. And so what it says is Morningstar publishes ratings data on 1,208 companies. A sample of 40 of these stocks is contained in a file named Morningstar. Use the set to answer the following questions. So part A says develop a point estimate of the proportion of stocks that receive Morningstar's highest rating. So the highest rating is a 5-star. So the first thing we need to do is how many stocks do we have? So I'm using count A, and I'm just using this range B2 to B41. I'm using count A because these aren't numbers, this is actual text in this column. Then I'm looking for, in that range, the ones that are 5-star. So what I did is I did count if. I want to do this range here, B2 to B41, and I'm looking for something that matches B34. So let me hit escape here, change this back to absolute, and you'll see why I'm doing that here shortly. B34 actually contains a value 5-star. Now what I could do is do Control C and just copy that here, Control V, and you can see that it's centered. And what I will do then is change, instead of using B34, I'll use this, move this down a little. I'll use this value here, and I'll still get the 2. So as I scroll down to answer part A, what proportion of the stocks that receive Morningstar's highest rating? So that's nothing more than this value divided by this value. So the answer is 5%. So part B, and you could label that a little clearer, you could actually say the proportion is for high star ratings is 5%. So B is develop a point estimate for the proportion of Morningstar stocks that are rated above average with respect to the business risk. So what do we need for above average? So we see right here in this column, we've got business risk, so we really want the above average. So what we'll need here is I'll copy this down, and that's not going to work. So we'll just build our formula. So we're going to do a count if. The range we're going to use starts right here, goes to the top, and we're looking for, that should have been a comma, and we're looking for, there's different ways you can do this. You just got to make sure you spell it exactly the way it is in your column, or we could have referenced a cell. We would have just needed to reference or put that above average right here. And then we could have just, instead of doing above average in quotes, we could have used the cell reference, which was this, gives us the same value. The proportion now is going to be this value divided by this value, or 42.5%. And then part C says develop a point estimate for the proportion of Morningstar stocks that are rated 2 stars or less. So how many have 2 or 1 star? Right? So how are you going to get that information? So again, if we do the 2 star, Control C, And we can scroll down through there. We do have some 1 stars. Control V. So equals count if the range is going to be this area, and what we need to match is the 2 star, but we also need to add the 1 stars. So we're going to count this same range again, except the criteria this time is going to be the 1 star, and we get 8. So the actual solution then is equal to this divided by our total number of stocks, which is 20%. And what we probably would want out there is something to the effect of this. And what I'm going to do is I'm going to format that. And I'm going to wrap that text and merge that text in those 2 cells. And you would have something like that. The next problem I want to do for you is problem number 7. It says a college board reported the following mean scores for 3 parts of the SAT. Assume the population standard deviation on each part of the test is sigma equals 100. All right. So for A, we've got, for a random sample of 30 test takers, what is the sampling distribution of X bar for scores on the criteria, the critical reading part of the test? So critical reading is 502. Okay, so 502 is the expected value, right? The sampling distribution is sigma divided by the square root of n, and n is 30. So what we've got then is equals SQ. So we want the square root of a number, and that number is going to be hold on, sigma this is sigma divided by square root of this, which is 18.26. So that's the answer that I would have been looking for. So B says, for a random sample of 60 test takers, what's the sampling distribution of X bar for scores on the mathematics part? Well, mathematics was 515. Again, the sigma is 100, except this time we have 60 taking the test. And so what we can do is we can, because we've laid this out similarly, copy this down, and notice it's D7 divided by the square root of D8, which is 12.90. Okay, and I probably should label these. If I were turning this in, you would probably go to the insert, and you'd insert a symbol, and you'd find sigma. So I just went out on the internet and typed how to put in the sigma symbol, the lowercase symbol, So you press the Alt key, you hold that down, and you press 229 and you release, and it shows up. Okay, this is lowercase n, and then this would be our sampling distribution. So for part C, it says for a random sample of 90 test takers, what is the sampling distribution for scores of the writing? So writing was 494. And you notice that these numbers don't have anything to do with what we're calculating. It's the 100 and the sample size. And so if we just Control C, Control V, we see that the answer is 10.54, and that becomes the sampling distribution. And again, notice that the standard deviation, the standard error, they all have the same standard deviation. The standard error is smaller for larger sample sizes. The next problem I'd like to go over for you is number 12. The Wall Street Journal reported that the age of a first startup for 55% of entrepreneurs was 29 years of age or less, and the age of the first startup for 45% of the entrepreneurs was 30 years of age or more. Suppose you have, this is part A, a sample of 200 entrepreneurs will be taken to learn about the most important qualities of entrepreneurs. Show the sampling distribution of sample proportion, where the sample proportion is the sample proportion of entrepreneurs whose first startup was 29 years of age or less. All right. So we have to do some estimations first to see if it's going to be a normal distribution. So what we can do, and I'll just show you the solution here. This is what they're looking for. And I'm just going to scroll down here. Put that in there. And that really didn't come across the way I'd hoped. So hold on one second. So I'll just give you this the way it's written. So the first thing you got to do is show that it's going to be normally distributed. And we know that what you have to do is prove that n times p it has to be greater than 5, and n times 1 minus p has to be greater than 5. So n is 200, and the proportion of entrepreneurs that was 29 years of age or less was 55%. So 200 times 55% says that it should be 110, and n times 1 minus p, 200 times 0.45 is 90. So they're both greater than 5. So the mean and standard error of the sampling distribution, we can say the expected proportion then is 0.55, right? That's what we were given. So we've got a large enough n to show that. And then the standard deviation then, using our formula, is our 0.55 times 0.45 divided by 200. Take the square root of that, and that gives us this information. All right, the second part of number 12 says, suppose a sample of 200 entrepreneurs will be taken to learn about the most important qualities of entrepreneurs. Show the sampling distribution of mean proportion, where P bar is now the sample proportion of entrepreneurs whose first startup was 30 years of age or more. So you're working through the same sort of setup. So we work through the numbers again. 200 times 45 is 90, and n times 1 minus p is 110. They're both greater than 5. So the mean and standard error of the sampling distribution are the expected proportion is 0.45, and the standard error then is 0.0352 using the same calculations that we did above. So then part C goes on to ask, are the standard errors of the sampling distribution different in parts A and B? And as you can see, they were exactly the same. So this is because the numerator of the formula for sigma p, the standard error of p is p times 1 minus p. So whenever you have p times 1 minus p does not change and the sample size is the same, the standard error will be the same. All right, the last problem that I want to show you is problem 16. 16 says a sample containing years to maturity and a yield of 40 corporate bonds is contained in the file named corporate bonds. So I've opened that up on another spreadsheet. What is the sample mean years to maturity for corporate bonds and what is the sample standard deviation? So as you can see here, it says use Excel, and we see the sample mean is 9.7063 and the standard deviation is 7.9805. And so you could write that out and say that's how it's written. So it says using Excel do that. So let me switch over real quick. So I've got Excel here and I've opened up the file. What we'll do is we'll go to our data tab and we'll do data analysis. Just so you can see me. I'll click on data analysis and I'll do descriptive statistics. And I've already did this before, but let me move this down for you to see. The input range is going to be this area, B1 down to all of my 40. And I'm going to do columns again. The first row has a label in it. The output range, I'm just going to put it out to the side as E1. I want summary statistics, and I'm going to go ahead and do the confidence level just to save some time for you. I'll hit OK, and so it puts it out. Now I had to widen these columns to see everything, but this is where the numbers came from. So the number here, this is the mean. So I might want to just highlight that as the mean. Standard deviation is right here, and so that gives me exactly what the book had given as an answer. So part B says develop a 95% confidence interval for the population mean years to maturity. So again, that's years to maturity. We did the 95%. And so we want that T alpha divided by 2. And so what we're looking for is this confidence level, 95%. So what we'll have is our, just like we saw in the book, we've got our mean of this. So plus this, lower limit, upper limit. So we would have plus this minus this level. And for the upper limit, it is this one plus this one. So our lower limit is 7.15, upper limit 12.26, and that should contain 95% of the time the actual mean for the years to maturity. So if we come back over here, we can see that the solution here is you can actually work it out. You could take your standard deviation divided by the square root of n and multiply it by t.025, and you would come out with the same numbers that I just generated on the screen. Now you might be wondering, okay, if I had to do this by hand, where did I get this 2.023? Well, that 2.023 can be gotten if you use that formula t.inv.2t. So 1 minus the 95%, which is 0.05, and the degrees of freedom, since we've got 40 here, would be 40 minus 1, or 39. And so that's where that value came from. So I didn't want you to think that I made it up out of thin air. Okay, but doing the descriptive statistics will give you all of this information, so you can come up with this value here that you need. Part C says, what is the sample mean yield on corporate bonds, and what is the sample standard deviation? And Part D says, develop a 95% confidence interval for the population mean yield on corporate bonds. So you can use Excel to generate the same information, just use the different column. So here we have the sample mean is 3.8854%, standard deviation of 1694. D is equal to, and I'll continue to go down here, do all the calculations, and we can see that it's a range of 3.3674 to 4.4034. That's the proportion of yield would be 95% of the time within that range. All right, so let's flip over here, and we'll just put it in G column. So I'll just say data analysis, descriptive statistics. The input range is going to change. It's actually going to be column C now. Columns, the output range, I'm going to make it G1. We want summary statistics and confidence level. We'll hit OK. And I'll just scoot over here, wind that up. We can scroll down a little bit. Let me keep moving that over for you. And we can see we get the same value here. And the standard deviation here. And we've got our confidence level here. So if I set this up identically, I can copy that here, and we get the exact same values that were listed in the book. Almost. They probably have some rounding errors. So I'm noticing what I did wrong here. So apparently I have one less. We're just throwing everything off. So let me double check that again. So again, data analysis. And that should be all the way to 41 because we have 40 observations. We're going to overwrite. So that's that information. It literally overwrote my formatting as well. That one. It's a little better. 3.36 to 4.4033. 3. So there's a little rounding, but fairly close to what I just showed you the book got. And so that's how we would get those solutions. Hopefully doing these and walking through them will help you solve the problems that are due for this week. And that's all I have to say for this one.